Good morning, students. Today we are going to discuss the second and the last part of the solution of 8.2 exercise, that is of the quadrilateral. So let's start with it. This is our question number 4. In this question, it is said that ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal, and E is the midpoint of AD. A line E drawn through E parallel to AB but intersect BC at F. Show that F is a midpoint. So this is the question number 4. So let's begin with the answer. Here we have EF is a line which intercepts DB at G. Let us assume that there is a line EF that is already given and it intercepts BD at G. By converse of midpoint theorem, we know that a line through the midpoint of any side of a triangle and parallel to the other side bisects the third side. So this is the theorem which states converse of MPT. Okay, here first we are going to consider the triangle ABD. So this left hand side triangle. Here E is a midpoint that is already given. So EF is a line which is parallel to AB and E is a midpoint. Therefore we get G will be a midpoint of DB. Since EF is a line which passes from a midpoint and parallel to AB. So EF is parallel to AB. So we can say that G is a midpoint by converse of MPT. Now EF is parallel to AB and AB is parallel to CD. So we can say that EF is parallel to CD. So these two lines are again parallel to each other. Now we will consider the right hand side triangle, that is BDC, this triangle. Here GF is a line which is parallel to CD. Since AB is parallel to CD, so we can say GF is a line which is parallel to CD and G is a midpoint that we have already found out just before. G is a midpoint of a line BD. Therefore, using converse of midpoint theorem, we can say that F is a midpoint of BC. So we can prove that F becomes a midpoint of BC using only converse of midpoint theorem. So this was our sum number 4. Now sum number 5. Here we have a parallelogram ABCD. E and F are the midpoints of the side AB and CD respectively. We have to show AF trisects the line AF and EC trisects the line BD, that is the diagonal. Trisects means we have to prove that DP is equals to PQ is equals to QB. This is what we need to prove. That is AF, this line, and EC, this line, trisects. Trisects means in 3 parts. So this is part 1, this is 2, and this is 3. In 3 equal parts, the line BD is divided. So first given is already provided. To prove, we know that we have to prove DP is equals to PQ is equals to QB. This we have already said. Now E and F is the midpoint of AB and CD respectively. This is given. So half of AB is AE. Again half of CD is CF. It is said that ABCD is a parallelogram. So since it is a parallelogram, we have AB is equals to DC and AB is parallel to DC. So from this line AE, we can say that AE is equals to CF as AB is equals to DC and parallel to each other. So we can say AE is equals to CF and AE is parallel to CF, which implies again that AECF is a parallelogram. So we got a parallelogram AECF. Okay, now we will consider the triangle ABP. So we are considering the triangle ABP, this triangle. Here E is the midpoint and EQ is parallel to AP, as AE is parallel to CF, as ACEF is a parallelogram. So we can say that EC is parallel to AF. Since it is a parallelogram, we can say AF is parallel to EC and AF is equals to EC. We can say this. So using this part, we can say EQ, which is a part of a parallelogram, EQ is parallel to AP and Q is a midpoint. Q becomes a midpoint by converse of MPT. Since E is a midpoint and EQ is parallel to AP, we can say Q is also a midpoint. Since Q is a midpoint, so we can write PQ is equals to QB. In the side PB, we can always say Q is a midpoint, so it says PQ is equals to QB. This is our relation 3. Similarly, when we consider the top triangle, that is DQC, this is D, this is C, DQC, we have FP. So since AECF is a parallelogram, so we can say PF and CQ is also parallel and F is a midpoint. So by converse of MPT, we can say P is also a midpoint of DQ. Following the previous part, as we have proved Q as a midpoint, so in this case we will prove P is a midpoint. Since P is a midpoint of DQ, so we can write DP is equals to PQ. Now this relation 3 and this relation 4 together, we can write it as DP is equals to PQ is equals to QB. So we can prove that the line AF and EC trisects the diagonal BD. So using converse of midpoint theorem, we have proved that two lines which have midpoints in their individual lines can bisect a diagonal can trisect a diagonal, that is divided into 3 equal parts. Now the sixth question says that show that the line segment joining the midpoint of a opposite side of a quadrilateral bisects each other. That means we have to show EG and FH bisects each other. Here ABCD is a quadrilateral given. EF and EG are line segment joining the midpoints. Since EF, G and H are the midpoints, so we have joined the midpoints. We have to prove that EG and EF bisects each other. So to do that, we need to do a construction. That is, we need to join EF, FG, GH and HE. So we form a quadrilateral EFGH. And we will draw the line AC, join the line AC. Now in this triangle ABC, so we have A, B and C. In this triangle, E and F are the midpoints of AB and BC respectively. So by midpoint theorem, here we need to write midpoint theorem. By midpoint theorem, we can say EF is parallel to AC and EF is half of AC. Similarly, G and H is midpoints of CD and AD respectively. So we can say HG is half of AC and HG is parallel to AC using MPT, midpoint theorem. So from this relation 1 and 2 together, we can write EF is equals to HG and EF is parallel to HG. Since this two line EF and HG is equal and parallel, so we can say this quadrilateral EFGH is a parallelogram. Using the property, a quadrilateral is a parallelogram if its one pair of opposite side is equal and parallel. So now we have this quadrilateral EFGH as a parallelogram. And we know the diagonals of a parallelogram always bisect each other. So since this is a parallelogram, GE, EG and HF are the diagonals of this parallelogram and they will always bisect each other. So our sixth one is also proved using MPT and the property of a parallelogram. Now we have come to the last sum of this exercise, that is sum number 7. Here ABC is a triangle at right angle triangle at C. So at C it is 90 degree. A line through the midpoint of M of a hypotenuse AB and parallel to BC intersects AC at D. Show that D is a midpoint of AC, MD is perpendicular to AC, and CM is equals to MA is equals to half of AB. So these three things we need to prove. So first we will write the given and then to prove. Here we need to do one construction, that is to join CM. So wherever we need to do any construction, we need to write it before we start our proof. So construction here is join CM. Okay, now we'll start our proof. In this triangle ACB, M is the midpoint. So M is the midpoint and DM is parallel to BC. M becomes a midpoint and DM is parallel to BC. So by the converse of midpoint theorem, we can say D is also a midpoint of AC. So the first one, that D is a midpoint of AC, is proved using converse of midpoint theorem. Now the second one. Here angle ADM and angle ACB are corresponding angle. This angle ADM and this angle ACB are corresponding angle. This we can understand as this line, the DM and CB are parallel and AC is the transversal. So we can get angle D and angle C as corresponding angle. Now it is given that angle C is 90 degree. So since it is corresponding angle and equal to each other, so we can say angle D is also 90. Now angle ADM plus angle CDM is 180. Since at D we have linear pair, that is at the point D the total angle will be 180. So ADM is already 90. So CDM will be 180 minus 90, that is equals to 90. So we can say that MD is perpendicular to AC. So MD, this line, becomes perpendicular to AC. So it is also proved. And the last one is we need to prove CM is equals to MA is equals to half of AB. For this, we already have AD is equals to CD since D is a midpoint. Now we will consider the triangle ADM, that is this shaded triangle ADM, and CMD, this dotted triangle. So here AD is equals to CD, we already have this from 1 since D is a midpoint. Angle ADM is equals to angle CDM, both are 90 and DM is a common part. So by side angle side congruency rule, we can say these two triangles are congruent to each other. Since these two triangles are congruent, that is ADM is congruent to CDM, we can say CM and MA are equal. So CM and MA becomes equal to each other. And M is the midpoint. So M is also a midpoint. So we can write MA is equals to half of AB. Since M is a midpoint, so we can write AM is equals to half of the full side AB. And from relation 2 and 3, we can write that CM is equals to MA is equals to half of AB. So our third part is already proved. So these were the 4 sum set of exercise 8.2 that we have discussed today. I hope this tutorial is helpful for for you to understand these sums. Thank you.